Oh my God, हिबा कितना टाइम लग रहा है आपको? Okay, guys, please listen. In the last lecture, we saw that the formation of hydrogen molecule. Okay, we saw the formation of hydrogen molecule, and we saw the molecular orbitals of hydrogen gas. And those molecular orbitals, it is going to use two atomic orbitals, and two atomic orbitals are going to give you two molecular orbitals. One of the molecular orbital will be bonding molecular orbital, the other will be anti-bonding molecular orbital. Okay, bonding molecular orbital is given as sigma, and whatever atomic orbital you are using to make that sigma bond. So we are making the sigma bonding orbital with 1s, it will be sigma 1s. And similarly, the anti-bonding will be what? Sigma star sign, just to denote that it is anti-bonding, and 1s because that anti-bonding is being made from 1s orbitals. The energy of one sigma 1s, that is bonding molecular orbital, is lower. Energy of anti-bonding is higher. And we fill the electrons in a molecular orbital very similar to the way we are going to fill electrons in atomic orbital. That means whatever is lower in energy, that orbital is going to get filled first, and then further we will move upwards. Okay, and then we'll move upwards. Now please write the next one, formation of He2. Okay, in hydrogen only, I will talk about one particular more thing, that is bond order. Please write a topic, bond order. Hiba, I have not received your message. हमने गलत नंबर भेज दिया क्या आपको? 0998007. No, that's right. Yes, Hiba. What happened? Hello, Assalamu alaikum, Waziha. How are you? I think Tarif also joined, na? Yeah,
Fine,
Tarif
sir.
also.
Walaikum.
Yes,
Yes, sir. Assalamu alaikum, sir.
Walaikum assalam. How are you, Tarif? Fine.
Sir, fine, sir. How are you, sir?
I'm good. I'm good. Thank you. Okay. Right. Bond order. Okay. So bond order is given by the formula. It will always be a number. So bond order, it is equal to number of electron in BMO, that is bonding molecular orbital, minus the number of electron in ABMO, anti-bonding molecular orbital. Fahad, assalamu alaikum. How are you? Divide by 2. Am I audible, Fahad? You can't turn your mic on. बहुत दिन हो गया आपकी आवाज सुने हुए. You can't turn your mic on, it seems. Okay. Fine. So number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. Okay, so we'll look at hydrogen. So please write for H2, hydrogen molecule. For hydrogen molecule, bond order will be equal to. Tell me the number of electrons in bonding molecular orbital. How many electrons are there in BMO of hydrogen? How many electrons are there in BMO of hydrogen? Please tell me, guys. Look at the last class. Iram, Fahad, Hiba, Tarif. Please tell me. Look at the last class. Na? We drew the molecular orbital. Identify what is the bonding molecular orbital and then message me. In the Zoom chat itself, okay? Yes, Iram, tell me, how many electrons are there in bonding molecular orbital of hydrogen?
2.
Okay, so I will have to take your name, then only you will answer. Yes, what happened, other guys? Tarif, Waziha, please answer, okay? Number of electrons in bonding molecular orbital is equal to 2. Waziha, tell me, how many electrons can you see in the anti-bonding molecular orbital of hydrogen gas? Yes, Waziha, tell me.
Sir,
In
0.
ABMO, 0. Yeah, very good. 0. And this will be divided by 2. That means bond order is equal to 1. That means it is going to have, and we know that hydrogen molecule, it has only how many bonds? It has only one bond. Okay. this homodicuclear molecule, it has one bond. So bond order is equal to 1. Now we are going to look at, please write this down. I hope you're writing with me also, because very small things are here. Okay, moving on. Now, when bond order is equal to 1, that means bond exists between hydrogen gas. So I can say that H2 exists. Okay, H2 exists. Now write formation of, or rather I can write MOD of He twice. Okay, so we'll see whether helium twice can exist or not. Okay, helium twice. Now what I'm going to do, first of all, I'm going to write the electronic configuration. What is the electronic configuration of helium? Tell me, guys. Electronic configuration of helium is, प्लीज बोलिए, इरम, हिबा, तारीफ, वजीहा, अब्दुल्ला. अब्दुल्ला, व्हाट इज द एटॉमिक कॉन्फ़िगरेशन? एटॉमिक नंबर बताइए चलिए, हीलियम का एटॉमिक नंबर. अब्दुल्ला, अब्दुल्ला, टर्न योर माइक ऑन एंड टेल मी. हिबा, आई गॉट योर मैसेज, थैंक यू. यस, हीलियम का क्या है एटॉमिक नंबर हीलियम का? अब्दुल्ला, टेल मी. You said something, I could not hear that. Can you please repeat that? Yes, Abdullah. No, I can't hear you at all. Iram?
2.
Yeah, 2. 4 उसका क्या है? 4 is what? For helium, it is the atomic mass. And इरम, आपको आंसर आता रहेगा, माइक ऑन करके आप बोल दिया कीजिए, नाम लेना नहीं पड़े. ठीक है इरम?
Okay.
हाँ, same is for everyone else also. Okay. हिबा, आपको पता था what is the atomic number of helium? हिबा?
Sir, 2.
2 है ना? आता है तो फिर प्लीज माइक ऑन कीजिए, जवाब दीजिए. Same goes for तारीफ, फहद, वजीहा and all of you guys. Okay. So helium atomic number is what? It is 2. So we will have the electronic configuration as 1s2. The atomic orbital that we are going to use is what? 1s of helium. So we write atomic orbitals in the left and right sides. And we have what orbital? 1s. We have 1s orbital here and 1s orbital. So there's only one orbital in the s subshell. This is also of helium. This is also of helium. So this will contain how many electrons? It will contain 2 electrons. This is also going to contain 2 electrons. And then we are going to draw the molecular orbital for both of these things. So the molecular orbital will be having, there will be 2 molecular orbital formed. One will be ABMO and the other is going to be BMO. Okay. Now, this is the molecular orbital. So this is 1s. This is 1s. So this bonding molecular orbital will be of what? Tell me. It will be sigma or pi. Sigma or pi, guys, please tell me. Sigma or pi?
Sigma.
Sigma. Sigma made by 1s, so it will be sigma 1s. And what will be this one? Sigma star, right?
Antibonding.
Yeah, sigma star. Correct, very good. Sigma star 1s. Acha, total how many electrons do we need to fill? Tell me. How many electrons do we need to fill? Total how many electrons do we need to fill in the molecular orbital?
4.
4. ठीक है तो now which of these orbitals is going to get the electron first? Sigma 1s or sigma star? Which is going to get the electron first? Sigma 1s or star?
Sigma 1s.
पहले? Very good, because it is lower in energy. I'll start with here 1 electron. I will pair it up 2 electron, 3 electron and 4 electron. Okay. Now one more thing is that if you remember, we wrote electronic configuration for atomic orbitals and different atoms. So there is also electronic configuration for molecules. So electronic configuration of, please write, electronic configuration of He2 will be sigma 1s, जो lower energy, that will come first. Sigma 1s, it is having how many electrons? 2 electrons. Sigma 1s, like this, 1s2. And then we are also having what? Sigma star. This is also having 2 electrons. So you can write it like this. Okay. So this is the electronic configuration of a molecule. If you for you are going to write for hydrogen, it will be just till here. Okay, sigma 1s2. Okay, only that. So this is the electronic configuration of helium. Now we are going to write the bond order. So bond order, it is equal to the number of electrons in bonding molecular orbital minus the number of electrons in anti-bonding molecular orbital divided by 2. So tell me what will be the bond order for He2? Number of electrons in bonding molecular orbital, BMO. Tell me how much. इरम, हिबा, तारीफ, अब्दुल्ला आप बताइए बॉन्डिंग में कितने हमारे पास है. अब्दुल्ला टेल मी. वजिया वेट अ सेकंड. अब्दुल्ला कैन यू सी द बॉन्डिंग मॉलिक्यूलर ऑर्बिटल? यस अब्दुल्ला. नहीं, बॉन्डिंग मॉलिक्यूलर ऑर्बिटल दिख रहा है आपको? which is bonding sigma 1s or sigma 1 star, which is bonding इन दोनों में से which is bonding molecular orbital? tell me. sigma 1. so उसमें कितने इलेक्ट्रॉन्स हैं? how many? proper तो ठीक से बोलिए. how many electrons are here in sigma 1s? 3 है. कहाँ से 3 है? 2 है ना अब्दुल्ला. why are you saying 3? and how many are there in sigma star? 2. tell me what will be this value? tell me. 2 minus 2 upon 2 will be equal to, please anyone answer fast.
Zero.
Zero.
0. Yeah. Hiba, you're trying to say something?
No, sir.
No. Was there anyone who was trying to say something else? No. Okay. That means bond order is equal to 0. That means there is no bond between helium and helium. And if there is no bond between helium and helium, we can say that He2 does not exist as bond order for He2 is equal to 0. Please draw this down. Raise your hand if you're done. Raise your hand when you're done. Waiting for Fahad, Hiba, Tariq, and Abdullah. And I think Waziha, are you done?
Yes, sir.
Keep your hand raised. Okay, keep your hand raised. Okay, everyone is done. Great. Chali. Now we are going to take a little pause. Okay. Because abhi pause लेने की जरूरत नहीं. Let's we can go a few steps more. Right. MOD of Li2. सबसे पहले we are going to write the electronic configuration, right? Yes or no, please tell me. है ना?
Yes.
So tell me. What is the electronic configuration of lithium? Atomic number कितना है lithium का?
50.
If it is 3, so electronic configuration will be 1s2,
1s2, 2s.
2s, 1. Correct? Yes or no?
Sir.
Okay. Now we are going to draw. अच्छा ये बताइए, which is having more energy, 1s या 2s? किसके पास ज्यादा एनर्जी है? Which is having more energy, 1s or 2s? हाय हाय.
2s.
ठीक है. 2h is going to have high energy. ठीक है. Whatever is coming afterwards, that is going to have higher energy. That is why we are filling the electrons first of all in the 1s orbital, because it is having lower energy. then we are filling in the 2s. Okay, so 2s is going to have higher, 1s is going to have lower energy. And if you remember the point, I wrote that this y-axis, it denotes the energy, right? So this denotes the energy. That means I'm going to write the 1s here, and the 2s will be here, right? This is your 1s, this is your 2s. This is 1s of what? Lithium. And similarly, you are going to have another lithium atom with 2s, another lithium atom with 1s. 1s, you are going to get 2 orbitals. 2s से भी आपको क्या मिलेगा? 2 ऑर्बिटल मिल जाएंगे. Okay. Now this 1s is having 2 electrons. This 1s is also having 2 electrons. इन दोनों से आपके पास, अच्छा, फिर यहाँ पे आपके पास 1 इलेक्ट्रॉन है, यहाँ पे आपके पास 1 इलेक्ट्रॉन है. ठीक है. तो दिस इज योर सिग्मा 1s, सिग्मा 2s, नहीं सॉरी, सिग्मा 1s स्टार. ये आपका क्या हो जाएगा? सिग्मा 2s, बिकॉज दिस सिग्मा बॉन्ड इज मेड बाय 2s ऑर्बिटल्स, एंड दिस विल बी व्हाट? Sigma star 2s. I hope all of you understood the molecular orbital diagram. Yes or no, please tell me. Abdullah, Tarif, any doubt?
Yes, sir.
Yes.
ओहो, हिबा को अभी रिकॉर्डिंग चाहिए, अभी देखिएगा आप हिबा. हाँ हिबा, are you going to watch the recording right now?
No, sir.
हाँ हाँ ठीक है,
Or
हम भेज
after
रहे हैं. Yeah. आप बताइए इलेक्ट्रॉन्स की फिलिंग कैसे होगी? हाउ मेनी इलेक्ट्रॉन्स वी हैव टू फिल, टेल मी. यहाँ पे देखिए कितने इलेक्ट्रॉन्स हैं, एंड यहाँ पे देखिए कितने इलेक्ट्रॉन्स है, बताइए.
3, 3,
3 कितना हो जाएगा टोटल?
6.
So we have to fill 6 electrons. सबसे पहले इलेक्ट्रॉन्स कहाँ पे जाएंगे? The lowest energy is 1s. 1, 2, 3, 4, 5 and 6. Done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
ठीक है, अब देखिए. Now calculate the bond order. बताइए नंबर ऑफ बॉन्डिंग कितने हैं?
4,
4 बॉन्डिंग. एंड एंटी बॉन्डिंग?
2,
So this will be equal to how much?
No, 1.
1.
1. So bond order is 1. That means there is a bond that exists between lithium and lithium. So we can say that lithium 2 exists. Okay, lithium 2 exists. Got it, guys? What will be the electronic configuration of this lithium 2 molecule? Lithium 2 molecule will have electronic configuration. Boliye please. Sigma 1s2, and then
Sigma
sigma
is
star,
bonding 1s2,
sigma star, then sigma
2s1, 2s2.
2s2, sigma 2s2. Very good. Okay. Now, one thing also I want to make very clear. देखिए, if you look at this part, यहाँ पे आपको दिख रहा है, like can you see that 1s orbital, its bonding is getting cancelled by anti-bonding? Can all of you see that? Yes or no? Please tell me. The
Yes,
number
sir.
of electrons in the bonding is equal to the number of electrons in anti-bonding. That means both of these are cancelling each other. That means even if I don't take this part and I only take the valence shell and draw the valence shell, I take into consideration the number of electrons in the valence shell and then draw the molecular orbital diagram, then also I will be getting the bond order 1. Yes or no? Please tell me. And this will be as it is. Correct, guys? Yes or no? Please tell me.
Yes, sir.
ठीक है. Okay. लिख लिया आप लोगों ने? Yes or no? Please tell me. Acha, also one more thing I want to tell you guys. Till 17th of November. No, not till 17th of November. Till 16th of November. Most of your classes will be of 1 hour. Okay. After 16th of November, I will be resuming like 1.5 hours to 2 hour classes. Okay. I'm at my mom's hometown. Yeah, I'm at my mom's hometown, so I have to visit some places, and most of the people are free after Maghrib prayers, right? And I am busy after Maghrib prayers, so it becomes very awkward in that sense. And the people in the village are like, "Babu आया है और time भी लेके नहीं आया है." So that is why I have to make time for some people. So just bear with me for more 15 days, and after that I will be having 1.5 hours. Okay.
Okay.
Okay. And I think we have joined by Aisha. Assalamu alaikum, Aisha. How are you?
Walaikum assalam, sir. Alhamdulillah, I'm fine. How are you?
Okay, I'm also good, alhamdulillah. But I mean, you're fine, but you're also late.
I'm sorry, sir. I became busy.
You got
Inshallah, next
busy.
time. Inshallah, next time I'd
Okay.
like to join.
Okay, fine. Okay, tell me what school is yours?
I'm from ISR, International Indian School, Riyadh.
Okay, yeah, okay, fine. Do you know any of your seniors? Yes, Aisha? Aisha, you're not audible now.
Yes, sir?
Do you know any of your seniors?
No, sir.
No, none of your seniors. Okay. I think there are 2-3 students who are in the 12th batch. Achha. Which chapter is going on in Riyadh? Oh, I can't hear you sometimes. Which chapter is going on? You don't remember?
Yes, sir. It's the Unit 7.
Unit 7 chapter's name bataiye na. Please tell the chapter's name.
Equilibrium, yeah.
Equilibrium is going on. Okay.
Yeah.
Chemical bonding is done.
Yes, sir.
Okay, fine. So you just like be here. Okay. I will talk with you after a while. That means after the class ends. Just be here and try to understand whatever you can make of it. And then I will give you my number. You message me. I will send you the recorded lectures of the earlier classes. Okay.
Okay,
And
sir.
then it will be helpful for you. Okay. Chali.
Thank
Now,
you.
the guys who were listening here, please listen. So that means what I can do, I can ignore the core shells, right? These atomic orbitals are in the core shells, right? This 1s is not taking part in the bond formation. The bond is formed only via valence orbitals, or we can say the valence shell atomic orbitals. Fine. Similarly, we are going to draw for MOD of beryllium. Please write. BE2. Molecular orbital diagram of BE2. Okay, BE2. Electronic configuration of BE2 is what? Sorry, not BE2, but rather electronic configuration of beryllium is what? Atomic number बताइए पहले. What is the atomic number for beryllium? Atomic number for beryllium. Very good. 4. Very good, Iram. Electronic configuration.
1s2, 2s2.
1s2, 2s2. Very good. Okay. Now, I hope. Can all of you draw the molecular orbital diagram? Yes or no? Please tell me. Except Aisha. I think Aisha may not, or C may also. What about others? Iram, you can draw MOD of BE2.
I don't know.
Yes or no? You don't know why? कैसे start करेंगे बताइए. चलिए, Iram, you only tell me. First of all, the y-axis gives me energy. Correct? Iram, can you keep your mic on?
Yes.
Okay. Now, you read this point. Na? I wrote all of these points. आप इसको पढ़िए. Okay. You read this point. Molecular orbital diagram. There are only 3 different. There are 3 steps. Y-axis shows the energy. Combining atomic orbitals are arranged on the left and far right of the diagrams. Right? चलिए. अब बताइए, what are the atomic orbitals that we have to draw? far left and far right. Okay, tell me. What are the atomic orbitals that I need to draw here in the far right and far left?
Far right it is anti-bonding.
नहीं, atomic orbital ना. पुराने आप नोट्स नहीं लिखे हैं क्या? ऊपर देखिए ना, इसका कैसे किया था लिथियम का. I hope you have drawn those things, right? आपने बनाया था ना इरम?
Yes, sir.
हाँ, तो क्या लिखते हैं वहां पे बताइए. एटॉमिक ऑर्बिटल बताइए, कौन से एटॉमिक ऑर्बिटल्स हैं हमारे पास बेरिलियम में? बेरिलियम के पास कौन से एटॉमिक ऑर्बिटल हैं? टेल मी. If anyone wants to answer, they can raise their hand. If anyone wants to help Iram. No one. Iram, at least tell me what are the atomic orbitals of beryllium? It is written in the screen. See and tell.
1s2 and 2s2.
हाँ नहीं, 1s and 2s. वो तो 2 तो इलेक्ट्रॉन बताता है ना इरम, right?
Yes, sir.
है ना? So what are the atomic orbitals of beryllium? Can all of you tell me? Waziha, Hiba, Tarif, Abdullah. 1s and 2s. Which is lower in energy?
1s.
1s.
1s, है ना? And 2s is energy में higher है. Okay, so it will be having. अब ये बात है कि obviously, tell me, do we require this 1s or will it be fine if we just write 2s? Because bond is getting formed by 2s only. You remember from the last point? Yes or no? Please tell me, guys. You remember from
Yes.
the lithium
Yes,
case?
sir.
है ना? So we will only take into consideration the 2s. So this is I have drawn. This is 2s of beryllium, and here also I will draw in the same energy level. Na upar na niche, right? Because 2s of beryllium will be having same energy as that of another beryllium's 2s. Okay. So this is one beryllium atom. This is another beryllium atom. This is the 2s of this beryllium. This is the 2s of this beryllium. And then we are going to draw the MEB, molecular orbital. One molecular orbital and then the another molecular orbital. इतना तो आता होगा आप लोगों को. आप लोग इरम ने तो कह दिया कि नहीं, हम तो कर ही नहीं पाएंगे.
Yes, sir.
इरम अब आ जाएगा.
Uh-huh.
Yeah. Okay. Then what do? We fill the electrons in the atomic orbital. So 2s has how many electrons? 2s has how many electrons? Tell me.
4.
4 नहीं है ना, 2 है ना. यहाँ
सर
पे
दोनों
2
साइड, मैं दोनों साइड
नहीं,
कह रही
एक
थी.
एक करके. नहीं वो नहीं कहना आपको, एक ही साइड करके, है ना. 2s and 2s. ओके, चलिए अब बताइए, अब टोटल इलेक्ट्रॉन्स कितने आ गए हमारे पास?
4.
हाँ, वेरी गुड. बिफोर दैट, व्हाट इज द नेम ऑफ दिस? What is the name of this atomic, sorry, this molecular orbital?
Sigma 1s.
नहीं, ये सिग्मा बॉन्ड किससे बन रहा है? कौन से एटॉमिक ऑर्बिटल से बन रहा है?
2s.
हाँ इरम, 2s ना इरम,
Yeah.
है ना? And the sigma star will be from also 2s. चलिए, sigma 2s में how many electrons will me? How many electrons in sigma 2s? How many electrons in sigma 2s? अरे रे रे, टोटल इलेक्ट्रॉन्स 4 हैं, तो 2 तो जाएंगे. अरे नहीं, एक सेकंड, आप लोग क्यों चुप क्यों हैं यहाँ पे? How many electrons do we need to fill? Yes or no? Please tell me. How many electrons do we need to fill?
2.
2 electrons.
एक टोटल बताइए, टोटल
अच्छा,
कितने इलेक्ट्रॉन?
total 4.
2.
टोटल 4, है ना? एक ऑर्बिटल में मैक्सिमम कितने इलेक्ट्रॉन जा सकते हैं?
2.
How many? 2. So sigma 2s में कितने इलेक्ट्रॉन चाहिए?
2.
सिग्मा 2s 2, एंड सिग्मा स्टार में
2.
हो गया. अब बताइए यहाँ पे बॉन्ड ऑर्डर क्या हो जाएगा इसका? NB minus NA upon 2. Number of bonding molecular, number of electron in BMO. Number of bonding molecular orbital electron. Tell me how many? Number of electrons in BMO.
4.
Number of नहीं, इससे देख के बताइए ना. 1s2 को छोड़ दीजिए.
2. 2 minus
और
2 upon 2.
हाँ, वेरी गुड. इरम आ रहा है आपको? इरम,
हाँ सर, आ
तारीफ,
रहा है।
फहद, हिबा, आ रहा है ना? वेरी गुड। चलिए अब ये बताइए, देखिए ना, अब थोड़ा सा आपको यहाँ पे केयरफुल होना पड़ेगा। अब थोड़ा सा आप मेच्योर हो जाइए और यहाँ पे यू विल टेल मी व्हाट इज द इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ Be2 फॉर। अच्छा ये बताइए, Be2 एग्जिस्ट करेगा नहीं करेगा? टेल मी, इट विल एग्जिस्ट और नॉट एग्जिस्ट? बॉन्ड ऑर्डर इज 0,
Not exist.
नॉट एग्जिस्ट। वेरी गुड। तो आपसे सवाल क्या करेंगे पता है? दे विल आस्क यू बाय मॉलिक्यूलर ऑर्बिटल डायग्राम शो Be2 does not exist, or they will ask Be2 does not exist, explain through molecular orbital diagram, or they will just say why Be2 does not exist, है ना? 3 मार्क्स का सवाल रहेगा तो MOD है। If it is of 3 marks, then you have to draw the MOD. Even for 2 marks, you have to draw the MOD. Okay. Be2 does not exist. Now the electronic configuration of Be2 molecule. Now please remember that this 1s will be also forming sigma, and that sigma will be sigma 1s2, and then sigma star 1s2, which will be cancelling each other out, so that there is no bond due to the sigma 1s and sigma star 1s, right? And then we have what? Sigma 2s, 2 electrons and sigma 2s, and then again sigma star 2s2. Is everyone clear with this electronic configuration? Yes or no? I hope you can see that there is sigma 1s2 and sigma star 1s2 even without writing it. Yes or no, guys? Please tell me. Can all of you see that? Yes. Iram, Hiba.
Yes, sir.
Yes, Hiba. Yeah. Okay. Please write this down. Raise your hand when you're done. Okay. Aisha, are you writing or you're not writing? I mean, you can.
Yes, sir, I'm writing.
Okay. Write and then raise your hand once you're done. Others, you all can lower your hand. Okay. I think everyone is done now. Now, Aisha लिख लिया आपने? Okay, very good. ठीक है. Now, we are going to study a phenomena. Okay, we are going to study a phenomena which is very important. Understanding के लिए आपको जरूरी है. Okay. Now, these are the small things where you figure out that you are now in what standard? You are now in your 11th standard. Okay. आप 10th standard से आगे आ चुके हैं. Now, there is a complexity. If you remember, can someone just flip some pages and tell me what are the conditions for the LCO, linear combination of atomic orbital? What are the conditions for that? Flip some pages. I will also go a bit back and then we are going to read that, because something interesting happens after when once p orbital comes into the picture, something interesting happens there. Okay. So I think it was in the last class. What was the necessary condition? 3 conditions, no? For the combination of atomic orbital. What are the conditions? Tell me. combining atomic orbitals should have same or slightly different energy, right? Can all of you see that? Yes or no? Please tell me.
Yes.
Okay. Then also they should have same symmetry, right? If one is symmetrical, the other should be symmetrical. If one is unsymmetrical, the other should be unsymmetrical. Then combining atomic orbital should overlap to the maximum extent. Okay. These are the three conditions. Now let us talk about the p orbital. Okay, let's talk about the p orbital. Now I'm going to make for 2s. Okay, 2s and 2p. 2s and 2p. This is one of the 2s. This is another 2s. And then 2p will be higher in energy. Yes or no? Please tell me, guys. 2p will be higher in energy. Yes or no? अरे हाँ ना, कुछ तो बोलिए.
Yes, sir.
है ना? Very good. Now this is 2s. This is 2p. Don't draw it. Okay, don't draw. Just listen. 2s, 2p. So 2s is going to give you some electrons here. 2s is going to give you. Now you can also draw this straight dashed line. This will be your sigma 2s. This will be your sigma star 2s. Okay. Now listen for the 2p. In 2p, we are going to assume what is the internuclear axis. Tell me. Generally, what do we take internuclear axis as? Tell me, guys.
Z.
Z axis. Very good. Z axis is internuclear axis. Now, this 2p will be having px, py, pz. Now, px, py, pz. So when this pz is going to move, when this pz is going to interact with each other, they are going to form sigma bond. Yes or no? Because internuclear axis is Z and the pz is interacting. So we'll get sigma 2pz. Clear है सबको? Yes or no? Please tell me. Is this clear? Till here? Yes or no? Please tell me. ठीक है.
Yes, sir.
Now, similarly, we are going to get sigma star 2pz. Similarly, what we are going to get? Similarly, we are going to get sigma star 2pz. This will be your sigma star 2pz. Acha. Now, from the px and py, okay? So pz is going to form sigma. Px will form what? Tell me. Sigma or pi? Px क्या form करेगा? Sigma or pi? Tell me, guys.
Pi.
Yeah, very good. It is going to form pi. And what about y? What will y form?
Pi.
हाँ, very good. px pi and py pi. So, ये बात सबको समझ में आई या नहीं है? Please tell me. If you do not understand, I will just give you a quick revision. All of you got this? Yes, Abdullah, Sari, Hiba. Yes, ठीक है.
Yes, sir.
अब ये बताइए, which is more stable, which is more strong? Tell me that. Which is more strong? Sigma or pi? कौन ज़्यादा strong?
Sigma.
Sigma is more strong. More strong. That means it will be having lower in energy, right? Because the attractions are more in sigma bond. And that is why when we are going to draw the pi bond, the pi bonds are going to be having slightly higher energy than the sigma ones. Okay. So this is your pi 2px and pi 2py. This is your pi star 2px and pi star 2py. Okay. Is this simple case okay for you guys? Yes or no? Please tell me. For the second shell, which is involving 2s and 2p. यहाँ तक clear है? ठीक है, यहाँ तक clear है. अब थोड़ा सा और आप like just in the last class only, we also looked at the shapes of different molecular orbitals, right? Shapes of different orbitals. Now, can you tell me what is the shape of sigma 2s? Sigma 2s is something like this. Okay, assuming that it is having positive sign. 2s ka? Yes or no? Please tell me. Just check the sigma 1s and 2s will be same but with larger size. Just check the sigma 1s. देखिए ना, लास्ट क्लास में करा था, है ना? ये sigma 1s है, sigma 2s भी वैसे ही होगा but this will be a bit larger in size. Okay? This is the same. अरे हाँ ना, कुछ तो बोलिए. This is sigma 2s, yes or no? No, what happened? This is the shape of sigma 2s. नहीं आ रहा है? What about others? वजीहा, इरम, तारीफ, इरम, तन्वीर, माइकॉन. हाँ ना, कुछ तो बोलिए, जल्दी जल्दी बोलिएगा तब तो होगा.
हाँ सर.
इरम, अरे हाँ तो बोलिए तो. हाँ वजीहा, व्हाट अबाउट यू? सिग्मा 2s सही है या नहीं सही है?
सर एक्चुअली ये वाली क्लास मैंने ली नहीं थे,
फिर आपने रिकॉर्डिंग भी नहीं देखा?
वो 2 क्लास मिस हो गई थी ना, एक का देखा है, एक का भी देखना बाकी है।
अच्छा ठीक है, तो आप मान लीजिए इसको. ओके, दिस इज योर सिग्मा 2s. अच्छा, सिग्मा 2pz का कैसा होता है शेप? सिग्मा 2pz का होता है कुछ इस तरह से. यहाँ पे नेगेटिव साइन, यहाँ पे नेगेटिव साइन. इरम आप बताइए सही है? इरम, फहद, आई थिंक दोस बोथ ऑफ यू गाइस अटेंडेड द क्लास. सिग्मा 2pz सही है? नोट्स में देख के बताइए. है ना सही? अच्छा. Now what happens? These two molecular orbitals, these two orbitals are what? These two orbitals are having very similar energy. Because क्यों similar क्यों है? Because देखिए both of them are what? Sigma bond. Both of them are sigma bond. Then another thing is देखिए shape भी same है. Look at the symmetry. Both are symmetric. Okay. Then what do we get? We get once again. What do we get? We get once again the combination of these two orbitals. कौन से दो ऑर्बिटल आप combine कर रहे हैं? Tell me guys, what are the two orbitals combining? Sigma 2s. Sigma 2s combines with sigma 2p. ठीक है, इसी को क्या बोलते हैं? 2s 2p मिक्सिंग. क्या बोलते हैं इसको? What is this called, Iram? Tell me. Yeah, वजीहा, इरम.
2s2p mixing.
और we can also call this sp mixing. क्या बोलते हैं इसको? We can also call this sp mixing. बताइए, NCERT में है ये या नहीं है? जैसे इरम, टेल मी, इज दिस इन NCERT? आपके क्लास में हो चुका है ना? यस इरम, NCERT में है या नहीं है?
तो हमारी टीचर ने तो नहीं पढ़ाया है.
आप NCERT खोलिए अब. All of you open your NCERT. खोलिए आप लोगों ने चैप्टर 4.
यस सर, इट वाज देयर, बट सर टीचर ने तो नहीं पढ़ाया था.
आपको दिख गया कहाँ पे है?
यस सर, जहाँ पर एस पाई बॉन्ड और सिग्मा बॉन्ड.
पाई बॉन्ड और सिग्मा बॉन्ड. पेज नंबर बताइए, कौन सा पेज नंबर देख रही हैं आप? वजीहा, व्हाट इज द पेज नंबर इन NCERT? Okay, see. Page, look at the page number 131. There is a diagram.
116.
नहीं 116 में नहीं होगा. SP मिक्सिंग आपके पास 131 में अच्छे से दिया हुआ है.
अच्छा.
116 में तो नहीं होगा. वन 131 में जाइए. देयर इज अ डायग्राम, एमओ डायग्राम, जहाँ पे होगा आपके पास अलग अलग ऑर्बिटल्स बने हुए होंगे. येलो रंग का बैकग्राउंड होगा.
सर एक्चुअली मेरा 116 पे ही है.
अच्छा, वो आपका 116 पे है. ओके
हाँ.
ओके, फाइन फाइन फाइन. ठीक है, तो मे बी 131 और 116. ओके, इन दोनों में से किसी एक पेज में कैन यू सी देयर रिटन विदाउट SP मिक्सिंग एंड विद 2s2p मिक्सिंग? Iram, Fahad, Tarif, Abdullah, Waziha, can all of you see that? There are two different cases, with 2s2p mixing and without 2s2p mixing. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
है ना? So देखिए, इसको भी ध्यान से पढ़िएगा. NCERT में है. Okay, don't think that अगर आपके स्कूल में नहीं पढ़ाया गया तो NCERT में नहीं है. It is there in NCERT. Okay, fine. And now please listen. 2s is going to combine with 2p. अच्छा, which is having lower energy, 2s या 2p? Tell me guys, sigma 2s या sigma 2p, कौन सा किसका lower energy है? Look at the graph, look at this MOD and tell me. We have the sigma 2s here and we have the sigma 2p here. Which is lower in energy?
2s.
अरे देख के जल्दी, हाँ, very good. Sigma 2s is lower in energy. Sigma 2s is lower in energy. Okay. Now, when I am going to draw the MOD, or when I am going to draw the bonding molecular orbital and anti-bonding molecular orbital of sigma 2s and 2p, I will write here, this is my sigma 2p, and my sigma 2s will be somewhere here, lower in energy. बात समझ में आ रही है सबको? And both of these are going to combine and they are going to form two different, one orbital higher in energy and one orbital will be lower in energy. Okay. अच्छा, अब ये bonding और anti bonding नहीं है, because both of these are made from this new molecular orbital. This set of new molecular orbital is made from what? It is made from only bonding molecular orbital. Okay, sigma bond. See, BMO से बना है. So both of these are bonding molecular orbital. Though, so how are they named? ठीक है, MO से जब MO बनता है तो उसको नाम कैसे दिया जाता है? Please listen. When these two new orbitals are formed, are you guys with me till here? Yes or no? Please tell me. ऊपर तो नहीं जा रहा आपके सर से? All of you are with me? Iram, tell me.
Yes.
इरम बताएंगे, इरम साफ साफ बता देती है कि समझ में आ रहा है नहीं आ रहा है। आ रहा समझ में?
हाँ आ रहा है।
आ रहा है ना? ठीक है। अब देखिए, since this which is lower in energy, it is near to sigma 2s, तो इसका नाम हमने क्या रख दिया? It will be having more properties of sigma 2s because it is having similar energy to sigma 2s. ये this is my new sigma 2s, ठीक है? And this sigma 2p, it is having a bit higher than 2p, so it is what? Again, it is nearer to sigma 2p, so this will be now my new sigma 2pz. नेमिंग ही समझ में आ रहा है आपको? yes or no? Please tell me. नेमिंग समझ में आ रहा है? yes or no?
Yes sir.
अरे हाँ ना, ठीक है। Now what has happened? Sigma 2s got a bit lower, है ना? देखिए sigma 2s यहाँ पे था, sigma 2s यहाँ पे आ गया है। And what happened to sigma 2p? ऊपर गया या नीचे? Got a bit lower या higher? sigma 2p के साथ क्या होता है?
हायर।
Very good. Higher. ठीक है? Sigma 2p got a bit higher and passes the pi orbitals. ठीक है, अगर आप याद कीजिए तो सिग्मा 2p के ऊपर कौन था? सिग्मा 2p के ऊपर कौन था? सिग्मा 2p के ऊपर पाई था। कैन ऑल ऑफ यू सी दैट? दिख रहा है आपको? हाँ या ना बताइए। दिस वाज सिग्मा 2p,
हाँ सर।
है ना? इसके ऊपर क्या था? पाई था। सिग्मा 2p थोड़ा सा ऊपर गया तो किसके ऊपर हो जाएगा? पाई के ऊपर चला जाएगा। बात समझ में आ रही है आपको? यस और नो? प्लीज टेल मी।
Yes sir.
ठीक है, ओके, वेरी गुड। नाउ सी, there are two different, we have to learn two different cases of what? Two different cases of energy of the molecular orbital. Please, आपको ये बात समझ में आ गई? It's fine. You don't need to write this down. Okay, you don't need to write this down. Just write this order of energy. Order of energy of MO, in which we have two cases. Case 1, when the number of electrons is greater than 14. In this case, there is no sp mixing. इस केस में क्या होता है? नो sp mixing. अब वो भी क्यों नहीं होता हम बताएंगे. ओके, नो sp mixing. अब अगर sp mixing नहीं होता है, then you will be having a very simple case जहाँ पे आपके पास क्या होगा? सबसे पहले सिग्मा 1s और 2s होगा, फिर 2s और 2 आई मीन सिग्मा 2s सिग्मा स्टार 2s, सिग्मा 2pz, फिर पाई स्टार, फिर 2pz का सिग्मा स्टार. ओके, सिंपल केस होगा वहां पे. प्लीज सी, देखिए सबसे पहले क्या आता है? सिग्मा 1s, फिर क्या आएगा? सिग्मा स्टार 1s, then we'll have 2s, so sigma 2s, then it will be sigma star 2s. 2s के बाद you will again make sigma bond with 2pz, sigma 2pz. फिर sigma 2pz के बाद क्या आएगा? pi bond आएगा. तो pi, this pi due to 2px will be having same energy as that of 2py. So both of these are same. अब pi के बाद क्या आएंगे? Pi star आएंगे. Pi star 2px equal to pi star 2py. And after the pi star, you will have sigma star 2pz. बात समझ में आ गई? Yes or no? Please tell me, guys. All of you got this? Yes or no?
Yes.
Sir, can you explain this part again?
हाँ. You know this sigma 1s will be there and उससे higher energy किसका होगा? अच्छा ऐसे आप देखिए शायद आपको समझ में आ जाए. Wait a second. Lowest energy will be with sigma 1s, and then after that we are going to form sigma star. It will be having higher energy than sigma 1s. Then next we will have sigma 2s and sigma 2s star, because 2s atomic orbital is going to make 2 sigma. One will be sigma 2s and other will be sigma star 2s. Okay, and after that you will be having 2pz. अब आप लोग देखिए. See, I have drawn nothing, but I have drawn. See, tell me. Tarif, you were having a doubt, na?
Yes, sir.
हाँ, अब यहाँ पे आप बताइए 2s तक हो गया. Tell me for after 2s what we are going to get next in energy
2p.
is sigma 2pz.
Sigma 2p.
Okay, what is
2pz.
2pz? Sigma 2pz. After that we are having 2 pi. Yes or no? One will be by
Yes,
x
sir.
and one will be by y. Okay. After that pi star. Yes.
Yes, sir.
After that sigma star 2pz. Got it?
Yes, sir.
Okay. And also देखिए, since sigma is having less energy, तो जितना नीचे आपके पास bonding molecular orbital होगा उतना ही ऊपर आपके पास anti bonding molecular orbital होगा, है ना? थोड़ा सा ऊपर नीचे होता है, but as a rule of thumb इस तरह से आप general rule of thumb आप याद कर सकते हैं. If the sigma is lower, तो sigma star उस that will be even more higher. Okay. जितना नीचे sigma होगा उतना ऊपर star होगा. Okay, this is for no sp mixing, right? Case 2. When number of electron is less than 14 or equal to 14. sp mixing होता है. sp mixing से क्या होता है? The only change that is going to happen with sp mixing is this sigma 2pz is going to get in between the pi. ठीक है, sigma 2pz कहाँ चल जाएगा? pi के बीच में चल जाएगा. बाकी सारी चीजें सेम है. So right, sigma 1s will be having lower energy and sigma 1s star. Then we'll have sigma 2s. Then we'll have sigma star 2s. Then we are going to have, अब यहाँ पे आपके पास क्या आ जाएगा? You will have pi 2px equal to pi 2py. Both of they are having same energy. Then you are going to get your sigma 2pz. After that you are going to get pi star 2px equal to pi star 2py, and then we are going to get sigma star 2pz. Done, guys? Yes or no? Please tell me. लिख लिया आप लोगों ने? हाँ या ना?
हाँ सर.
Yes, sir.
अब once again I'm going to explain कि ये 14 इलेक्ट्रॉन्स का क्या फंडा है ना। एंड ऑल्सो sp मिक्सिंग 14 इलेक्ट्रॉन्स से पहले होती है, उसके बाद क्यों नहीं होती है। ठीक है, देखिए क्या होता है। देखिए जब आपके पास 2p कहाँ पे आएगा, बोरॉन से 2p आ जाएगा, राइट। बोरॉन विल हैव 2s and 2p आल्सो। बोरॉन, कार्बन, ऑक्सीजन, नहीं बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन एंड देन क्लोरीन। ओके, इसको नियॉन भी लिख लीजिए आप अगर लिखना होता आपको, नियॉन। ठीक है, बोरॉन के पास कितने होते हैं इलेक्ट्रॉन, टेल मी गाइस। बोरॉन हैज हाउ मेनी इलेक्ट्रॉन्स, बोरॉन के पास कितने इलेक्ट्रॉन्स होते हैं, 5। यानी कि बोरॉन का जो मॉलिक्यूल बनेगा, B2 will have 10 electrons, C2 will have 12 electrons, okay, N2 will have how many electrons, 14. Oxygen will have how many electrons, 16, 18 and then 20, right? Yes or no, please tell me. 20, right?
Yes, sir.
अब यहाँ पे देखिए आप लोग, this is boron, okay. Now we are only focusing on two orbitals, 2s and 2p. 2s will be having lower energy, 2p will be having some energy which is similar to 2p. सेम केस होगा आपके पास। देखिए इस तरह से आप व्हेन यू आर गोइंग फ्रॉम बोरॉन टू फ्लोरीन, व्हाट इज हैपनिंग इन दिस केस, द इलेक्ट्रोनेगेटिविटी इज इंक्रीजिंग, राइट। ओके, तो कार्बन के जो एटॉमिक ऑर्बिटल्स होंगे दैट विल बी अ बिट लोअर देन दैट ऑफ बोरॉन। ठीक है, so carbon, because it is more electronegative, that means carbon has more number of protons. Please listen to this very carefully. Carbon has more number of protons, so it is going to attract the 2s electron and the 2p electron more effectively. That is why these orbitals will be having slightly lower energy than boron. Nitrogen में क्या होगा, you will have even further lowering of energy like this, okay, even further lowering of energy, 2s and 2p. Now if you remember this, this 2s is going to have 2 electrons. यहाँ पे बोरॉन के पास 1 इलेक्ट्रॉन होगा 2p में. Here carbon is going to have 2 electrons. In 2p it is going to have 2 electrons. Nitrogen is going to have 2 electrons in the 2s. In 2p is going to have 3 electrons. Okay, it is going to have 3 electrons. यहाँ तक if you see here, all of these electrons are in different orbitals. p में 3 ऑर्बिटल होते हैं and all of these electrons are in different orbitals. Pairing अभी तक नहीं हुआ है. And what is the benefit of not pairing? That means repulsion in the orbital is not very high. But as soon as I go to oxygen, in oxygen there is a lowering of the orbital's energy. But what happens due to the pairing of 2p electrons, this 2p does not get much lower, और उसके हिसाब से 2s बहुत ही नीचे चला जाता है. Okay, 2s is lowered so much. Why? Because to compensate for this particular pairing repulsion, there is a pairwise repulsion in these electrons, these 2 electrons, and to compensate for that, this 2s goes very low, and that is why there is a difference, a huge difference in energy when you have 2s and 2p of oxygen. Okay, difference in energy is what, very high due to electronic repulsion in 2p. Now all of you understood. Now if the energy gap is very high, therefore combination of 2s and 2p is not possible. All of you understood this? Why this is the barrier? What is the sweet spot? Nitrogen is the sweet spot. Nitrogen has 3 electrons. All of these electrons are in different orbitals, and that is why there is no repulsion. बात आ गई समझ में? Yes or no? Please tell me both of these things. sp mixing होता है, क्यों होता है? Because 2s and 2p, not 2s and 2p, sigma 2s and sigma 2pz, they are having same symmetry. They are having similar energy, right? And that is, they are also having same shape. That is why they combine with each other. And what is the result of that combination? The result of that combination is sigma 2s gets a bit lower, sigma 2s gets a bit lower, and sigma 2pz gets a bit higher. And that changes the electronic configuration of the, or I can say the order of the molecular orbitals, energy order of the molecular orbital. Okay, But what happens after 14? After 14, we have pairing in the 2p, which makes the energy difference between 2s and 2p very high. And since the energy difference between 2s and 2p is very high, the combination is not possible. Is everything clear till here? Yes or no? Please tell me. इरम बताएंगे. इरम, आपको समझ में आ रहा है यहाँ तक? ठीक है.
Yes.
Okay. Abdullah, you are with me till here. Hiba, you are with me till here.
Yes, sir.
ठीक है. अब आप लोग को इसको भूल जाना है. ठीक है. जस्ट एक बार आपने समझ लिया, पढ़ लिया, थोड़ा सा आप एक बार वाली एग्जाम से पहले एक बार इस लेक्चर को फिर से देख लीजिएगा. ठीक है. लेकिन बैक ऑफ द माइंड आपके पास पता रहना चाहिए कि एसपी मिक्सिंग होता है, क्यों होता है, 14 जो है वो क्राइटेरिया क्यों है ना. यू जस्ट कीप इन योर हेड. द मोस्ट इंपॉर्टेंट थिंग जो है वो हमने लिखा दिया आपको यहाँ पे, केस 1 एंड केस 2, and you will be very effective in what? Electronic configuration of any of the molecules. For example, अगर हम आपसे बात करें कार्बन मॉलिक्यूल के बारे में, C2. चलिए, सबसे पहले नंबर ऑफ इलेक्ट्रॉन्स बताइए कितना होगा C2 में. नंबर ऑफ इलेक्ट्रॉन्स विल बी टोटल नंबर ऑफ इलेक्ट्रॉन्स in C2. एक कार्बन में कितने इलेक्ट्रॉन? How many electrons in one carbon? One carbon में
6.
हाँ, तो C2 में कितने हो जाएंगे 2 कार्बन में?
12.
अब्दुल्ला, आपको ये नहीं पता है? एटॉमिक नंबर्स नहीं याद है क्या? अब्दुल्ला, तारीफ, हिबा, you guys don't know the atomic number? Yes or no? Please tell me fast.
So 6.
अरे वो नहीं पूछ रहे हैं हम, आता है नहीं आता वो पूछ रहे हैं. अब तो बता दिया सबने. एटॉमिक नंबर आता है हिबा?
Yes, sir.
ठीक है. अब्दुल्ला, आपको आता है?
यस सर.
आता है एटॉमिक नंबर. फ्लोरीन का बताइए. अब्दुल्ला, कीप योर माइक ऑन. अब्दुल्ला, कीप योर माइक ऑन.
यस सर.
अब मत बताइए. हमने पूछ दिया आपसे, आप माइक ऑन नहीं करके रखते हैं. उतने देर में तो कोई आदमी कहीं से भी देख के बता देगा. Be in the class when you are in the class, okay? Now tell me case 1 और case 2. Case 1 और case 2 जल्दी बताइए, जल्दी.
Case 1.
Case 1. पक्की बात, case 1. देखिए, case 1 है. नंबर ऑफ
Sorry,
इलेक्ट्रॉन्स
case
ग्रेटर
2.
देन, हाँ case 2 है ना. case 2 यानी कि सिग्मा 2pz बिटवीन पाई. ठीक है. पाई और पाई स्टार के बीच में क्या आ जाएगा? सिग्मा 2pz. बस इतना याद रखना. चलिए, प्लीज टेल मी, टर्न योर माइक ऑन. स्टार्ट कहां से करेंगे? You have to fill 12 electrons, okay? We have to fill 12 electrons. Okay, please start. Sigma 1s में कितने electrons? Tell me guys fastly. कितने electrons?
4.
अरे 4 कहाँ से आएगा? 2 आएगा. एक ऑर्बिटल में 2 इलेक्ट्रॉन. हाँ, एक ऑर्बिटल में 2 से ज्यादा नहीं. आफ्टर दैट कौन सा ऑर्बिटल आएगा? आफ्टर सिग्मा 1s we have
सिग्मा स्टार.
अरे हाँ, बोलिए, बोलने से मतलब
सिग्मा स्टार 1s2.
हाँ, उसके बाद
Sigma 2s.
उसके बाद
Sigma star 2.
उसके बाद
Sigma 2z.
सिग्मा 2z नहीं होगा. सिग्मा 2pz तो किसके बीच में आएगा? पाई. नहीं होगा ही नहीं. केस 2 देखिए, केस 2 2pz पाई के बीच में आ जाएगा. पाई हो जाएगा ना यहाँ पे.
पाई 2pz.
पाई 2pz.
Yes.
अरे पाई 2px.
हाँ 2px.
पाई 2px. अब देखिए, हमने ब्रैकेट लिखा है ना, तो पाई 2px और पाई 2py एक साथ आते हैं. ठीक है. कितने इलेक्ट्रॉन्स भर लिए हमने यहाँ तक? बताइए, हाउ मेनी इलेक्ट्रॉन्स आर फिल्ड टिल हियर? हाउ मेनी इलेक्ट्रॉन्स आर फिल्ड टिल हियर? अरे रे, कितने इलेक्ट्रॉन्स? 2 4 6
8.
8. जस्ट अ सेकंड. ठीक है. अच्छा 8 वी हैव टू फिल हाउ मेनी मोर 4 मोर, बट प्लीज लिसन, ये आपके पास जो ऑर्बिटल्स होते हैं ना पाई वाले इस तरह से है ना, इस तरह से है, इसमें आपके 4 भरने हैं, तो बताइए ये सही तरीका है भरने का? इज दिस द राइट वे टू फिल? यस और नो, टेल मी। प्रोसेस पे जाइए, एंड रिजल्ट पे मत जाइएगा प्लीज, ओके। लुक एट द प्रोसेस हाउ आई एम फिलिंग। फर्स्ट आई एम फिलिंग दिस ऑर्बिटल, then I am filling this orbital. Is this the right way to fill 4 electrons?
No.
No. Very good. कैसे fill करेंगे? नहीं, yes नहीं, no is not the right way. इरम बताएंगे, इरम बताइए कैसे fill करेंगे? पहले
सर
single
पहले
optical,
सिंगल,
हाँ, फिर डबल करेंगे, फिर पेयर करेंगे, ओके गाइस? जस्ट लाइक अभी तो आपको उतना फर्क नहीं पड़ेगा बिकॉज वी हैव 4 इलेक्ट्रॉन्स, सो यू विल फिल इट लाइक दिस। यहाँ पे सिग्मा जैसे ही पाए आ जाए ना, आप ऐसे फिल कीजिएगा 1 2 3 and 4. So we have filled from here also 4 electrons. So total कितने हो गए आपके पास? 12 इलेक्ट्रॉन फिल हो गए, ठीक है ना? यही आपको चाहिए, इससे आप क्या निकाल सकते हैं? बॉन्ड ऑर्डर, द मोस्ट इंपॉर्टेंट थिंग। फिर आप बताइए क्या एग्जिस्ट करता है या नहीं करता है? बॉन्ड ऑर्डर, टेल मी। नंबर ऑफ बॉन्डिंग माइनस नंबर ऑफ एंटी बॉन्डिंग डिवाइड बाय 2. नंबर ऑफ बॉन्डिंग इज इक्वल टू हाउ मच?
4 minus 0.
4 है बॉन्डिंग? नहीं, ज्यादा है बॉन्डिंग। स्टार तो सिर्फ 2 में है ना? हाँ 1s 2s को भी ले लीजिए, यहाँ पे लिख लिया ना
8
हमने।
minus 4,
तो 8 minus 4 by
4,
2, हाँ कितना आ जाएगा? कितना आ जाएगा आंसर?
2.
वेरी गुड, ठीक है। बट जानते हैं मॉलिक्यूलर ऑर्बिटल थ्योरी के मुताबिक, अकॉर्डिंग टू मॉलिक्यूलर ऑर्बिटल थ्योरी, कार्बन हैज 2 bonds and this bond is also pi, this bond is also pi, okay? सिग्मा है ही नहीं इसके अंदर। चलिए दैट्स इट फॉर टुडे गाइस, ओके। 1 घंटे का क्लास लिया हमने।